Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P219A, signifies an air-fuel ratio, AF, variation within one of the cylinders of the Honda HR-V, model year 2016 to 2022. This condition typically arises when there is an imbalance in the air-fuel mixture delivered to one or more cylinders, leading to inefficient combustion. The AF ratio is crucial because it determines the vehicle's performance and emissions. Variations can be linked to various components, including fuel injectors, ignition coils, and sensors that monitor and report this data to the Powertrain Control Module, PCM. The PCM then makes adjustments to optimize fuel delivery. Importantly, if the vehicle presents with additional DTCs, they should be addressed prior to focusing on the P219A code. This procedure ensures correct diagnostics and effective repair of underlying issues. DTC P219A pertains primarily to the air-fuel ratio, AF sensor, which plays a vital role in monitoring the air-fuel mixture in each cylinder. Its location is typically near the engine exhaust manifold, integrating itself within the emissions system. A failure in this sensor can lead to incorrect readings, misrepresenting the actual AF mixture and causing imbalance in cylinder performance. Additionally, fuel injectors are responsible for delivering the precise amount of fuel into each cylinder. Any malfunction can affect the AF ratio directly. If an injector becomes clogged or fails, it may either hinder or over-deliver fuel, leading to variations noted in the DTC. The ignition coils also contribute, as they control the spark that ignites the fuel-air mixture. Failure here can impede proper combustion. Proper inspection of all related components is crucial for accurate diagnosis and correction. There are several possible causes for DTC P219A, with the primary suspect being a faulty air-fuel ratio A4 sensor. This sensor's role is to monitor the effectiveness of the combustion process in each cylinder. If it malfunctions, it may not relay accurate data about the air-fuel mixture, leading to improper adjustments by the Powertrain Control Module, PCM. Injector malfunction is another critical cause. If injectors are clogged or damaged, they can either under-deliver or over-deliver fuel, which disrupts the optimal air-fuel mixture necessary for proper engine operation. A loss of engine compression can also lead to discrepancies in combustion efficiency, as low compression in one or more cylinders can cause significant imbalance. It is essential to investigate these components systematically to identify the specific source of the problem. The symptoms associated with DTC P219A often manifest through poor engine performance, as the imbalance in the air-fuel mixture can lead to inefficient combustion. This inefficiency may cause a noticeable drop in acceleration and overall power. Increased emissions are also a critical indicator, since the air-fuel ratio affects how completely fuel burns. An improper ratio can generate higher levels of harmful pollutants, causing the vehicle to fail emissions tests. Engine misfires may also be present, as uneven fuel distribution across cylinders can lead to periods where one or more cylinders fail to combust fuel effectively, leading to rough idling and potential stalling. Lastly, the PCM may activate the check engine light, prompting the driver to seek diagnosis and repair. The first step in troubleshooting DTC P219A involves confirming the issue. Begin by placing the vehicle in the on mode, where the ignition is activated but the engine is not running. Next, it's crucial to utilize the Honda Diagnostic System, HDS, to record several parameters, including vehicle speed, engine speed, manifold absolute pressure, MAP sensor readings, engine coolant temperature, ECT sensor, accelerator pedal position, APP sensor values, and air-fuel feedback AFFB adjustments. These parameters provide vital context for diagnosing the issue. Once recorded, start the engine and hold the RPM at 3000 without load until the radiator fan activates. This ensures that the engine operates under more consistent conditions. This allows for a more accurate diagnosis by performing a cylinder air-fuel ratio test 3 times under conditions where the AC and other electrical loads are turned off. In the second step, conduct a test drive of the vehicle while monitoring the same parameters recorded in the previous step. This real-world assessment helps establish if the issue persists under operating conditions. Pay careful attention to the OBD status through the HDS. It will indicate whether the P219A code is currently flagged as failed or passed. If the HDS indicates that the DTC has failed, it confirms that the failure condition exists, prompting you to proceed to the following troubleshooting step. Conversely, if the HDS indicates a passed status or an intermittent failure, it suggests the system may be functioning correctly under the current conditions. In such cases, review any freeze data and see if the failure can be replicated under similar conditions. At this stage of troubleshooting, switch the vehicle to the off mode in preparation for further diagnostics. Conduct an engine compression test to assess the health and integrity of each cylinder. This test measures the ability of each cylinder to hold pressure, which is essential for efficient combustion. If you discover that one or more cylinders exhibit significantly lower compression than the others, it strongly indicates an underlying problem within the engine that requires repair. This could involve issues such as valve problems, piston ring failure, or a blown head gasket. Should all cylinders measure within an acceptable range, you would then proceed to the next step to investigate further into valve clearances, as this may also affect air-fuel mixing efficiency. Continuing with the diagnostics, now it is time to inspect the valve clearance. The valve clearance is the gap between the valve stem and the rocker arm, a critical specification that impacts engine function. If the clearance is out of specifications, it can hinder valve operation, negatively affecting the engine's ability to breathe and adequately combust the air-fuel mixture. This blockage or inefficiency can contribute significantly to the symptoms observed with P219A. If the inspection confirms that the valve clearance is within acceptable limits, one can proceed to the next step, focusing on carrying out the cylinder air-fuel ratio test with the HDS again. In contrast, should the clearance be found lacking, adjustments will need to be made before testing further. At this stage, restart the engine again to verify the cylinder air-fuel ratio. Hold the engine speed at 3000 RPM without load, just as done previously, after ensuring that the AC and all other electrical loads are off. Performing another cylinder air-fuel ratio test will provide current data to assess whether the issue persists. Conduct this test 3 times as done earlier, documenting the results carefully. Should the results come back as okay, it might indicate an intermittent failure, pointing to a temporary issue or sensor error rather than a consistent problem. Consequently, if freeze data is available that correlates with this DTC, try to reproduce the failure, analyzing conditions that may have triggered it. If the results are not satisfactory, further diagnostics across additional components will be necessary. The 6th step involves evaluating the fuel injector specifically, as they can significantly affect the air-fuel mixture. Begin by turning the vehicle to the off mode, allowing for a safe interchange of components. Take the fuel injector from the suspect cylinder, the one noted for issues, and exchange it with a similar injector from a different cylinder. This process helps determine if the injector is malfunctioning. Restart the engine and again hold the RPM at 3000 under the same conditions. Conduct the cylinder air-fuel ratio test 3 times as earlier described. If test results indicate a failure at the cylinder where the injector was exchanged, it will confirm the injector is indeed faulty, warranting the replacement of all injectors as a set to ensure uniform performance across cylinders. Now let's inspect the exhaust gas recirculation EGR line for any buildup of carbon or sludge, conditions that can obstruct flow and affect engine performance. The EGR system recirculates a portion of exhaust gases back into the intake manifold to reduce nitrogen oxides, NOx, emissions, and improve efficiency. A clogged EGR line can lead to improper combustion and ultimately an air-fuel ratio variation. Start this inspection with a visual check of the EGR line. And if you notice any significant buildup, it's imperative to clean the intake manifold EGR port, the EGR pipe, and the EGR valve passage using an appropriate throttle plate cleaner. A thorough cleaning can restore normal EGR operation, enhancing overall engine function and addressing symptoms linked to DTC P219A. In the final troubleshooting step, conduct a visual inspection of both the intake and exhaust manifolds for carbon buildup. Carbon deposits can restrict airflow, impacting performance and the air-fuel mixture consistency. It's essential to note if you detect any such buildup. These restrictions may create improper engine operation, tying back to DTC P219A. If evident, assess whether there are any oil leaks that may contribute to this buildup. Repairs may involve cleaning the carbon deposits or, in severe cases, addressing engine oil leaks. If no signs of carbon buildup are present, this may suggest an intermittent failure. Ensure to reconvene with detected freeze data to reproduce any issues. Identifying and resolving these factors is instrumental for maintaining engine efficiency and reliability. Upon completing the necessary repairs related to DTC P219A, it is crucial to perform a final verification process. This entails confirming that all identified issues contributing to the DTC have been effectively addressed. Conduct a post-repair test to ensure that the vehicle is functioning normally and that the check engine light remains extinguished. Monitoring overall engine performance is the most reliable way to affirm that previous symptoms do not return. Ensure the air-fuel ratio is confirmed within specifications through successive tests. Checking for any additional codes with the HDS is also advisable, ensuring that nothing else has arisen during repair. Successful verification enables the technician to ensure the vehicle will operate efficiently, maintaining performance and adherence to emission standards. Preventive maintenance is integral in ensuring that DTC P219A relating to air-fuel ratio variations does not recur. Starting with regular inspections of the air-fuel ratio sensors can aid in early detection of issues before they escalate. Keeping the fuel injectors in working order by testing them periodically can help ensure that the right amount of fuel is delivered to each cylinder, promoting optimal combustion. Additionally, maintaining the cleanliness of the EGR system is critical. Regular checks and cleaning can prevent deposits from impacting performance. By putting these preventive measures in place, you can maintain engine efficiency, reducing the likelihood of similar DTCs appearing again. This vigilance not only enhances vehicle performance, but also extends the life of the engine. To conclude, understanding DTC P219A as an air-fuel ratio variation code is key in maintaining your Honda HR-V from 2016 to 2022. The diagnostic process begins with confirming the DTC, followed by a systematic approach to troubleshooting potential causes, which involve essential engine components like AF sensors, injectors, and EGR systems. Each troubleshooting step is designed to guide technicians through a process that isolates the exact issue responsibly and effectively. Lastly, establishing a routine of preventive maintenance can mitigate risks of repeating the DTC. By committing to regular inspections and repairs, you ensure a reliable driving experience with optimal engine performance over the vehicle's lifespan. Please like and subscribe to the channel. See you next time.